Okay, so the law of refraction is a fairly simple law to learn, and there are some amazing consequences. Things like rainbows, lenses, fiber optics, even simple pictures like this are just among the many applications that we have on refraction. The goal here, though, is for you to understand how does light bend? How can you predict the path it takes? So we're going to do a conceptual understanding first. Remember, when light goes from air into plastic, since the plastic is denser, it's going to slow down. Now, if there was just going from air to air, it would just go in a straight line. There'd be no bending. But in reality, when it goes from air to plastic, the light slows down, and it's going to bend towards the normal. So the refracted beam bends towards the normal. And then you measure those angles always relative to the normal. When you're going from something like plastic into air, rather than bending towards the normal, the beam is going to bend away from the normal. So here we have our incident beam. It strikes the surface, bends away from the normal. The refracted beam bends away from the normal. One easy way to remember this, if you are a fan of Superman, he used to say up, up, and away. So if the speed of the light speeds up, or if the light speeds up, it bends away, up and away, down, towards. So, yeah, all you have to do is figure out, does light speed up or slow down to know if it bends up, or it bends away or towards the normal. Again, the angles are measured relative to the normal. So all that's fine, but what about this is a conceptual understanding, what about an actual number? How can we predict the exact path it would follow when we use Snell's law? It was experimentally discovered by Wilbrod Snell, and so this is why it was named after him. So N1 represents the index of refraction of where the beam is coming from. Theta 1 is that incident angle. N2 represents the material that it's going into. So for instance, glass. So this N2 would represent the glass. Theta 2 would represent the angle of the refracted beam relative to the normal. Let's actually do a sample problem here. Let's figure out what is the angle of refraction. So we know N1, we know N2, we know theta 1. So of course, being the diligent student I am, I'm going to write down my variables. I'm going to write down my formula, and then solve this formula for theta 2. So I'm going to divide both sides by N1. I'm going to divide both sides by N2. So I get sine theta 2 is equal to N1 divided by N2 over sine theta 1. And then I'm going to take the inverse sine of both sides, which gives me the theta 2 by itself. Then I can plug in my numbers. So just make sure that your calculator is in degree mode when you're doing this, and keep your order of operations right, and you'll be golden. I was sitting in my car in the parking lot, and it was raining, and I noticed raindrops forming on the windshield, and this was an image that I captured with my camera. Sitting in the car looking out, I could see a flipped scenery in the individual raindrops. So having an understanding of refraction allowed me to not only notice this, but also understand it. And understanding is a wonderful thing that helped me enjoy that scenery even more. But that's it for now. Take care.